a true snow day is ever in our future again, Mr. King.
I know.
Even 2 hour delays, I'm wondering if they'll just skip the 2 hour delay or hour and a half
Make them
delay
virtual.
and just say, oh, we're going to have a virtual learning day today. I feel bad for the younger kids that they
They
might
should be
be.
out sled riding.
Yes. I mean, maybe not at 9:40, but I mean, by lunchtime or maybe by like 11 o'clock, you would think they would be out sled riding.
Bronx Hill should be full.
Yeah. I know. We live by Clover Hill Golf Course. It's in our neighborhood, and
Hmm.
usually it is filled with kids as well. So I am sure
Oh, I didn't know you could go there to sled ride.
you can, and it's pretty amazing, especially from the first hole to the second hole, and then I think it's hole 4 or 5. That there's another steep hill. It's a lot of
I'll
fun.
have to hit
Yeah,
that up.
yeah. So we usually drive, but we make our 13-year-old walk. But if I'm gonna go, I'm gonna drive down. Anyway, so today we are going to talk about solving absolute value inequalities, which you are going to see is almost identical to solving absolute value equations. A very easy process. An equation and an equality has just pretty much the same steps with one minor change, and we're going to show you that minor change today. So we're going to complete a couple of examples, and then we'll start the homework together. Hopefully it's a pretty straightforward day. Little reminder, since we are switching this week a little bit, Tuesday and Wednesday, if you are in group A, which is everybody from A through L, or if you flip-flop your days, you're coming to school on Wednesday to this week, Tuesday and Wednesday. So our remote learning day was switched to today, and then everybody still gets 2 days this week. So Tuesday and Wednesday is the new group. And then also, please take your attendance if you have not done so already. It was included in the email that was sent out to everybody in the district, the link, and it's also posted at the top of my page. But please submit your attendance today. Finally, don't forget to upload those notes for sections 4.1 to 4.3 and continue submitting those homework assignments. So we are going to go over into the note packet. So if you want to find your notes, this is section 4.5, solving absolute value inequalities. I'm going to go through the 3 warm-up questions with you just to review solving an inequality and graphing an inequality, because that's what we're going to work on today, but we're going to be solving these absolute value inequalities. So find that note packet or take out your Notability app if you use Notability. I think a lot of you, I think it's half and half for this class. Let's see if you can find your notes, and we are looking at section 4.5. So the first 3 problems want us to just solve the inequality. Anytime you have an inequality, your solution is always graphed, because it's not just x equals 5, it's x is greater than 5. So we're graphing and showing all of the solutions where x is bigger than 5. So answer solution is always graphed. So Bill, if you look at the first problem, how would you solve this inequality? What would you do first?
Minus it by 17.
Yeah. So that makes negative 57. And then what would you do, Bill?
Divided by 3.
Yeah. Do you know what 57 divided by 3 is, Bill?
Not off of my head.
Okay, I'm going to help. What's 60 divided by 3?
20.
So what's 57 divided by 3? 1 less.
19.
Yeah, 19. So x is greater than or equal to negative 19. We did not flip the sign because we're dividing by a positive, so no need to flip our sign. X is greater than or equal to negative 19. So on the number line, we know that we don't have to use 0 because we're at negative 19. So when we go to graph this, we might as well put 19, negative 19 in the middle. because it's nowhere near 0. And then just label it with a couple other numbers. Remember, the number line on the right side, the numbers get smaller. And then this is -20 on the left side. So label a couple of values on that number line. Jason, this says x is greater than or equal to. So at 19, are we placing an open or a closed circle because it's greater than or equal to?
Closed.
Closed. And then which way would you shade based off of the way the arrow is pointing, Jason?
The right.
Excellent. Going to shade to the right. So closed, shade to the right. All right, let's go through B and C a little quicker. That was a little refresher there. So the arrow is pointing to the right. We shaded to the right. Looking at letter B, we have 4x plus 7 is less than -1. So getting x by itself, just like Bill did for the previous problem, we'll subtract 7 and then divide by 4. X is less than -2. Again, there's no extra steps necessary here. So x is less than -2. We don't have to flip. We have x by itself. -2 is close to 0, so I can put a 0 in the middle. And then label some values on the number line. So Anya, if this just says less than, what do we place at -2? Open or closed circle?
An open circle.
Yeah, and then if you look at the tip of the arrow, which way would we shade, left or right?
Left.
Excellent. So shading to the left. So again, the arrow is pointing to the left. That's the direction we shade. All right, one more. This one kind of ties into what we will be talking about today. So we have two inequalities here. This is a compound inequality. We have to solve both. So both of them make up our inequality. We're going to subtract 1 and then divide by 2. So you have to solve one at a time. Subtract 1. So this is kind of similar to what we've been working with, and divide by 2. I have two inequalities. That's what makes it a compound inequality. X is less than -2, x is greater than 2. So on the number line, we can place 0 in the middle. Both of these are just less than or just greater than. They don't have the equal to, so open circle. And then look at the tip of the arrow. So my -2, it says less than. At +2, another open circle and greater than. So I have two that we're graphing because this is an or problem. Or you always shade the opposite or the outside portions of the number line. And that's going to tie into our inequalities that we're going to solve today that are in the absolute value form. Are there questions on the warm-up? All right, Mr. King's going to talk about the definition for an absolute value inequality. Well, at least show you what they're going to look like. There's a couple different cases that we might see, and then we'll go through the steps and solve a couple inequalities.
Good. So if you look at the absolute value inequality, basically all it is an inequality that has an absolute value. So in order to give you the definitions, I'm going to use the examples we used above. So if you look at A, well, an example of an absolute value inequality would be the absolute value of 3x plus 17 is greater than or equal to -40. So that's an example. Another example is if you look at B, the absolute value of 4x plus 7 is less than -1. Now, how we solve these absolute values are a little bit different because we're going to look, there's two different cases. One is going to be for when the values are less than an absolute value, and then the other one is when we're looking at greater than. And they're going to show, just like above, they had two different graphs. You had the first two just had one line, and then the last one with an or had two lines when he graphed. And it's going to be very similar for when we're looking at absolute values. So looking at our examples here, the first one where we have a greater than. And this also includes greater than or equal to. So if it's a greater than, you're going to have to use or. And I'll show you what this looks like in the example. So for our example here, we had the absolute value of 3x plus 17. It's greater than or equal to -40. Well, when we solve this, you're going to have two different options. You're going to have, you need to, again, flip the sign. So one is going to be 3x plus 17. And you remember how on the left we have a negative value? Well, if you put negative that -40, that's going to give you a positive 40. And on the left, you're going to flip that sign. So I'm going to go a little bit more detail on this. And then we have that word or. (3x plus 17) is greater than or equal to -40. So we're splitting this up into two different equations. Similar to how we did last section when we had equivalent equations with absolute values. The big difference is when you get a greater than symbol, in this step, you have to take the negative value of your constant and then flip the signs. If you have a less than, these are a little bit easier, actually a lot easier. And this is a, so if less than, this is an and. And then the way example this would look is we go above to 4x plus 7, and that was less than 1. Well, what we're going to do is we're going to put an and symbol here where this value is between, and again, we still take our negative and we put this value right between where the absolute value was. So I basically, all I did was rewrite the absolute value is less than 1, and then we added in this step over here where the 4x plus 7 is now in between -1 and a +1. So we're still flipping the sign, but it's in between. So it makes it a little bit easier. And I think it's going to make a lot more sense when we look at an example. I could do a little bit better job of explaining. So if we look at example A, Michael, are we going to have our absolute value in between with an and statement, or is it going to be two separate ones with an or statement? For example A.
Would it be an and?
Yeah, it's and, because if we notice here, this is less than, so we're going to use the and, or you could think of that as in between. So Michael, how would I rewrite this to get rid of the absolute value?
It would be -12 is less
Yeah.
than x minus 5, less than +12.
Yeah, 100%. And this is exactly how we solved in the past. We solved these before. Michael, how would we solve this? How would you get x by itself?
Add everything by 5.
Yeah. We add 5 to both sides of the inequality. Jason, what do we get as our final answer?
-7 very equal to x plus very equal to 17.
Yeah, -7 is less than or equal to x, which is less than or equal to 17. So now we want to graph this. So let's see if we can. So those are pretty far apart. So I'm going to go by twos. So I have -8. Let me get rid of go black. -8, -6, -4, -2, 0, 2, 4, 6, 8, 10, 12. Oh, got to add on a little bit more. 14, 16, 18. Okay, when we're looking at these, we have less than or equal to. So we're going to use a closed circle or an open circle. What do you think, TJ? I'm sorry, say that one more time. Is it closed circle or open circle?
It's a closed circle.
Yeah. So I'm going to go to -7. And TJ said put a closed circle. I'm going to go to 17. Put a circle. And then we're going to shade in between. Just like we did before with our inequality. You don't have to shade that thick. But... And that's it. So Anya, looking at the second one here, part B, are we going to look at an or an and?
An and.
Yeah. So can you tell me what I would write down for this and statement?
-5 is less than x plus 3 less than 5.
Yeah, that's it. And what would be our first step to solve? And our only step to solve?
Subtract 3 on all sides.
That's it. And I like the way you said that, on all sides. Yeah, so you get -8 is less than x, which is less than 2. That's it. So the and ones are actually a little bit easier than the or ones. You can see. So what you should really look at is you're first looking at the sign is really going to be your first step. And you want to see, should it be an and or an or? And that's going to help you separate them. So in this case, again, I'll just go by twos. Bill, are we looking at open or closed circles on -8 and 2?
Open.
Yeah. And are we going to shade on the outside or in between them?
Outside, I believe.
Okay, look if it's an and statement.
Or no, the inside.
Yeah, in between them. You got it. That's it. Ms. Kane, should we have them get out the homework? We could go through a couple with them.
No, I think we need to do 2 more examples with the ones underneath for sure.
Gotcha. You want me to do one in example 2 and one in example 3?
No, just do the 2 in example 2.
Okay, gotcha. All right, TJ, is this an and or an or statement for example 2A?
It's a and.
Yeah, it's an and. All right, so how do we set this up to solve?
Um, just you leave it the way it is, or do you have to flip anything?
So if you look above to example B, what do we do to that 5?
Moved it over. Or-
Yeah.
Yeah.
So yeah, you're right. You'd move it over and make it negative. So it would start with, tell me what to write down.
-7.
Yeah.
2x plus 3.
Yeah.
And then it's 7 again.
Yeah. So -7 is less than 2x plus 3, which is less than 7. So TJ, what would be the first step to solve?
Either add or subtract 7 to everything, or each side.
Okay, remember we want to get x by itself. So how would you get x by itself?
Then subtract 2,
Not 2.
3.
Yeah, you subtract the 3 from all sides. Jason, what do you get when you subtract 3 from all sides?
-10.
Yeah.
Right
Keep
on
going.
2x. Four.
Okay, is less than 4. Good. So -10 is less than 2x, which is less than 4. And Jason, what's our next step?
Divide 2 from each side.
Yeah, it's divide 2 from all sides. And then what do we get for a final answer, Jason?
-5. Less than x, less than 2.
Yeah, -5 is less than x, which is less than 2. So now we're going to graph. Nakai, is it going to be open or closed circles on -5 and 2? Anya, is it going to be open or closed circles on -5 and 2?
Open circles.
Open. Are we going to shade in between them or outside?
In between.
Yeah.
Mr. King, why don't we just do one of the example 3 so that they see one with a greater than symbol?
Yeah.
Maybe you can just like walk through it so that we could start the homework then.
Absolutely. So we look at example 3. It's greater than. So is that and or, Anya?
Or.
Or. So that means we need to break this into 2 separate inequalities. So on the one side, I have 2x plus 5. And this is the one we have negative. When you have a negative inequality, we're going to flip the sign. So instead of a greater than, this now is going to be a less than or equal to. Instead of a +3, it's now going to be a -3. So it's very similar to how we started the one with the equals, except we now flip sign and then we make negative. So if that was a -3, now it would become a +3. It becomes the opposite. And again, this is an or statement. So or, and then we keep it the same for the one on the right. So very similar to how we had the equations. The only difference is we're now flipping the sign for our negative one. All right. From there, we're going to solve in each one. And again, we could go across. First step is subtract 5. And then you get 2x is less than -8. On the right-hand side, you get 2x is greater than or equal to -2. Last step, divide by 2. And you get x is less than or equal to -4, or x is greater than or equal to -1. And now we're going to graph. So are any questions about how to solve? Okay, Michael, when I'm looking at this, are we going to have open circles or closed circles?
Close.
Good. So we're going to have closed circle on -4 and -1. Now, Michael, are we going to shade in between or on the outside if it's an or?
Outside.
Yeah. So we're going to go outside. So the first step is we're going to look at the sign. If it's less than, it's an and. If it's a greater than, it's an or. If it's an or, you're having two separate inequalities. You need to flip the sign and make negative. So if you want to go to Google Classroom, your homework's up. I saw it posted. Ms. Kane, do you want me to go through some of these? Did you want to go through some?
I'll do it if that's okay, because I want to show them which ones to do.
Yep, 100%.
So hopefully you're finding this on Google Classroom. We're going to go through the first 6 problems are not ones that you need to solve. So we're going to do the first 6 here, 1 through 6. But notice the directions ask you to write the equivalent compound inequality you would use to solve. So we're not solving these first 6 problems. We're just writing the compound inequality. So looking at the first one, the key thing that Mr. King just went over with you is that symbol. What does the symbol say? And this one is a greater than. So greater and go together. So this is an and problem. So you would want to make sure that you're separating this.
That's an or.
Oh, that's an or. I'm sorry, Mom. Greater or.
No problem.
Greater or. So think my fault here. If it says greater, I'm changing the way I'm spelling great.
I like that.
Or problem. So when it's or, I need 2. It's my brain fart there on a Monday morning, apparently. So I would write 2 inequalities. 3 minus x is less than -5. This is an or problem, so I need 2. 3 minus x is greater than 5. So greater means you have or, 2 options, 2 separate inequalities. And then the next one, let's look at number 5. This is less than. And I'm going to change the way I'm writing less than, and is when you have 1 inequality. It's an and problem. So when it's an and problem, you keep it the same, and then you include that -9 on the other side. So greater is or means 2 separate. Less than means those are included together. That's all you're doing for these first 6, nothing else. So 1 through 6, you're just writing the compound inequality. So look at the symbol. Greater is or, less than is and. And then the other problems I'd like you to do is 1 through 16. So pretty much the first page of this. There are problems on the other side. So 11 to 16 would be the next group of problems. Looking at number 11, first thing, the most important thing, look at that symbol. This is a less than. So less than is and. So take your inequality. There's my original one. Make it an and problem by putting the -8 on the other side. So less than and. And then we have to solve this. So this is an easy one to solve. We would add 3 to each piece, just like Mr. King showed you. So I would have a -5 is less than x, which is less than 11. And that's it. Now it's solved. Looking at the inequality, we have to go from -5 to 11. So maybe we should count by 2s on our number line. I'm going to start at -6 so that it's a little past -5. So when you're looking at those numbers, kind of gauge to see how close are they together, and that should help you label the number line. So -5 all the way up to 11, they're a little more spread apart. If I had a -5 to a -3, those are closer together. And then it's less than, not equal to, so an open circle in between 4 and 6, an open circle in between 10 and 12. And remember, this is and, so we're shading in the and region or in the middle. So and is always in the middle. Or is opposite, outside. Greater is or. Less than is and. So again, you're stopping at 16. So you're pretty much doing the 2 groups of problems on this first slide. Tomorrow, group A is in class tomorrow, and we will continue to work on a couple of more of these as practice. Does anyone have questions? All right, have a fantastic day.
Have a good one.